So, anyways, this. I mean, you could just continue this on from yesterday's notes. We're just still evaluating logarithms. I kind of thought this lesson would be wrapped up with fractions. I just was wrong. So, but good. Now we know how to do the fractional ones. But the trouble with this one, you notice right away, is that, well, if the thing I just said made sense, or you already knew that before you came in, you understand right away that 125 is not a whole number power of 25. Like, that's the problem. If I gave you log base 8 of 1 over 64, you see the easiness, the simplicity of this is that 8 can be squared to make 64, so the answer is -2. The rub here is like, well, what do I do with 25? What do I do to 25? Raise it to what power to make it 125? And therein lies the black magic, and this will not take long. So here's how it goes down. Step one is to put an equals x over here. So if you think about it, that is what we're trying to accomplish, right? We're trying to find the logarithm over there. So by putting a variable over there, it's going to allow us to actually construct an equation from what we understand about logarithms. Now, I don't think I ever explicitly drew this picture yesterday, but let me give you a simpler example so that we can get this little arrow diagram stuck in our heads, because I think it's time now to get it stuck. And so if I gave you something like this, log base 4 of 64, you guys understand that the answer is 3. Like, by now, that's easy for you guys, having practiced as much as you did. And where that comes to exist is from this fact. Follow the little blue arrows. 4 to the 3rd power equals 64. And it's that little arrow diagram that's going to answer a lot of questions within the next couple of weeks. It's the this to the this equals this to the this equals this, over and over again. So get that little science kind of, what do you call that, the water cycle or something, get that little diagram stuck in your head. So if I were to write like this white and blue one down here out in what we call exponential form, it would say, I think clearly, that 4 to the 3rd equals 64. Like, that's at the heart and soul of understanding how this works, right? Now, having said that, this is where we make the leap. If we understand that little blue arrow cycle, we can apply that blue arrow cycle to this problem. It's not going to be the everything we need, but it's going to be for sure the first step that we need. So if I do my little blue arrow diagram, I think this to the this equals this, over and over again. And we want to write it out. And so what's it going to say? Follow the blue arrows.
25.
Wonderful. That's step one. And I don't know necessarily that that's an I get it or don't get it thing. That's not the I get it step. That's just the do as you're told step. That's the base of the logarithm. Going to the power of the thing on the other side of the equal sign equals the argument of the log. Follow the blue arrows. They're your bestest buddies. Now, we're not out of the woods yet, because again, 25 and 125, like 25 is not something that you can just say, ooh, I'll take 25 and raise it to this power or this power. It's not intuitive like that. So kind of a big brain question coming. Can you think of something, a number that 25 and 125 are both powers of, DMAC? Yes. Good job, you guys. And so the breakthrough or the breakout step here is to understand now that I need to take those two things. And quite frankly, I think I'm going to redo my second box. I want to take the two things in the yellow boxes, and I'm going to write them both as powers of the thing that Delaney just said, and that is 5. I identified that they can both be built by 5s. Having said that, I can take this side, the left side, and I can write it now as 5 squared to the x, because that's 25, right? And having acquired just over time here and there little rules of exponents, you might or should remember that when you do a power to a power. Anyone remember what you do with those two exponents? You multiply them. Sometimes we would say add. If you were thinking that, you'd more be thinking of 5 to the second times a different 5 to the x. That's when you would do 5 to the 2 plus x. But that's not going to help us here. So we understand that these two powers, let me put a little red kind of jelly bean thing around them. Those two powers get multiplied together, giving us a singular power for 5, which is actually, I'm going to clean this up, 5 to the 2x. Does that make an ounce of sense? Now,
You only want the power of
the left side? No. I'm on now to the second yellow box, the right side. And having gotten through what we, your teacher erroneously forgot to tell you, but just did tell you like 8 minutes ago, we now know how to write 125 if it's on the bottom of a fraction, 1 over 125, as a power of 5. Anyone want to take a shot at that? Oh boy, 5 to the negative third. And that's where that the Delaney's little power sheet is going to help you. If you don't know if you don't have your powers memorized, you could look right down there and say, look at my powers of 5, go to the column that says 5 and go down to 5 to the third. And you're like, jackpot, there's the guy I'm looking for. And so we know 5 to the third is 125. So 5 to the negative third must be 1 over 125, right? Now comes the jump. I don't even think it's big brain logic. I think it's pretty obvious. If you tell me that 5 to the something equals 5 to the something else, what logical conclusion can we make? Nope. Nope. Oh, wait, I'm going to take a sip of coffee while you let that one simmer. What has to be true about those two exponents? You know what? You know that I don't mind when you guys sound dumb.
Wait, what's your question?
If I tell you that 5 to the something equals 5 to the something else, there's only one way this is going to work. What has to be true about those two red boxes? They have to be the same. Then see, it wasn't going to sound dumb at all. Oh, well, come on. You know, we're all friends here. We say dumb things. I do it all the time. So if I have a 5 with a power equal to a 5 with another power, my brain kicks in. And this is not something that's like a judgment call. This is a fact that 2x, whatever it is, has to be the same as -3. Those exponents, it's not up to me. They have to be the same if they're both matching powers of 5. And suddenly it goes from an algebra 2 problem to a 6th grade math equation. You're like, how do we solve for x? And we get x equals -3/2. And the reason this problem was challenging for us is, again, because we're searching for something that we're not going to find on a worksheet. We're not going to find it on a list of powers. We knew going into this that you can't take 25 and raise it to some whole number power and expect to get 125. It ain't happening. We know that. And that's why the answer is coming out fractionally like this. And so if I'm doing this problem in my delta, I just type in, what did I say? -3/2. Like that. Okay.
Oh.
Why did I put it as a negative?
No, you put it as a fraction and it wasn't.
No, it is.
I hate it when that happens, but I like your guys' sound effects. That was nice. Ooh, that was pretty rad.
What did you know?
Yeah, I don't know. I gotta go back. Hey, thank you.
It was a fraction. Yes, it was.
Hold on. I copied the problem. I yell at you guys for this all the time. I copied the problem down wrong. It's my bad. You guys are all yelling at poor Delaney. You're yelling at her like she's lost her mind. I copied the problem down wrong. Yeah. Well, I just did. I mean, do you see that? Look, it's blue. Do you see that number? Memorize that. What does that say?
No, it's not.
Okay.
Log base 25.
Log base 5, log base 25 of 120. You memorize 125. Wait for it. What's that say? I copied it down wrong. So if I did the problem correctly, if the delta math problem were 25, log base 25 of 1 over 125, my answer would have been rad. I just copied it down wrong. So of course the answer should be 3x, right? You guys want to go again? Right. I like that. I hope I don't mess up. I kind of hope I do mess up again, so you guys will all go, ooh, that was pretty rad. Whatever. That would have bothered me 20 years ago. Now, so are any of these fractions? Oh, there we go. Good. Nice. Let's do this one. Log base 16 of 1 over 8. Make sure I get this right this time. Log base 16 of 1 over 8. I think this is going to happen on all of them. I can't click through enough to verify this, but from what I've seen, the base of the logarithm is not going to match friendly like with the number that is in the argument of the log. So what's step 1? Yeah, so stick your x over here. Good job. So we say 16 to the power of x is equal to 1 over 8. Step 1 is to convert from what we call logarithmic to exponential. The log effectively goes bye-bye. All right, so who's our guy? What are we looking for? 16 and 8 are both powers of what number? They are not powers of 4 and they are not powers of 8. They are, however, powers of 2. I know for a fact that I can take 2 to some power and make 16. I also know that I can take 2 to some power and make 8. You cannot do it with 4s. You cannot do it with 8s. But 2s will work. So I'm going to take the left side and I'm going to write the 16 part of it in my mind as what? 2 to the 4th. So I'm going to skip a step here, and instead of writing it out like last time, because you get it now, I'm just going to write 2 to the 4x. I'm going to have to multiply those dumb things together anyways. And what am I going to write the right side as? It's going to be 2 to the something. 2 to the negative 3rd. Well done. Okay. And again, the logic kicks in, and I say if 2 to the something equals 2 to the something else, then the something and the something else have to equal each other, right? So the equation that I then derived from this is 4x equals negative 3 this time. So what's x? Negative 3/4. Done. Should we type this one in and see if we can avoid the ooze? I'm still a little scared. Yeah, a little gun shy here, so good. But you can learn from my mistake. Make sure you copy the problem down correctly. So like this.
So how did you write it down wrong last?
Because I like it when that happens. Because the problem literally last time, here, let me see if I can make this clear for you. I got to get this video done so the poor kids 7th hour when they're watching it can say, like, can we shut up? But they'll probably already quit watching because they get it. The problem said log base 25 of 125. I want you to know that that's what was in Delta Math. I wrote on the board log base 25 of 1 over 125, which changes the right side. The right side should have been 5 to the 3rd. My right side was 5 to the negative 3rd, hence the erroneous negative. Got it? Y'all better? All right. What do you think? Can you do this? It's not bad, is it? Once you know, like, if you don't know the trickery of it, it's like almost impossible. But the trick is the common base. All right. So there will always be a common base. We're not going to give you anywhere there's not a common base. So that's that.